Now this is genuinely new, and I definitely want you to watch this. It's about being precise in your work, because if you're not precise in what you're doing, it's very easy to get things kind of mixed up. So we'll talk a little bit about this. So in MATH6040, you get away with kind of saying differentiate, anti-differentiate. But in this module, there's going to be lots of different types of such a differentiation, so we need to be a lot more precise. For example, when we so rather than just saying differentiate, we're going to have to say, for example, I want to differentiate with respect to x. Now going back to functions for a second, so remember functions, you put a number in and you get a number out. So that's the objects you studied in MATH6015. MATH6040 we've seen in chapter 2, matrices, you have a vector in and a vector out. And basically what all a function needs is a collection of inputs and a collection of outputs. And this is where things are going to get a little bit confusing. You can put whatever you want as the input. I mean, you can define functions between any kind of collection of objects. But what I'm going to be interested in, more or less, is a function that sends, you actually input a function and get out a function. So you're not putting in a number and getting out a number, you're putting in a function and getting out a function. And typically these things we're going to call transforms. So more or less transforms are things that where you put in a function and you get out a function. And you have seen some transforms before. So for example, this, I have in mind a particular transform here that you put in a function and you get out a function. You put in the constant function 2 and you get out 0. You put in the line 3x minus 2, you get out 3. You put in the function x squared, you get out 2x. You put in sine x, you get cos x, e to the x, and log x, 1 over x. And if you want to pause for a second and think, what the hell is this transform? Pause. It's a perfectly good function, it appears. To each input, it assigns an output. Now, if I were going to say, if we were in class, you'd probably give me an answer of differentiate. And that's not too bad. Saying that this symbol, by the way, is a bar sign. That this is differentiate, so differentiate this. It's a function. We'll try and be a little bit more precise now and call it dx. Differentiate with respect to x. Now I've used the word transform, and that's probably not a terrible idea. The one actually I really want to use is operator. Now both of these are kind of terms. Transform you will see a lot next year. And if you go into level 8 you'll see it as well. Operator is the other kind of language. So transform or operator, they're both kind of good. Now the weird thing is here, these transforms or operators are functions, so that's why we call them some. And the problem is you put a function into them, so the input to the function is another function. That's confusing, so we call them operators. So the input to the operator is a function. So you give an operator a function, it spits out another function, or you give a function to a transform, it spits out another function. So as I said here, this view can be very confusing with a function and input to another function, so you can use the term operator or transform to describe a function that takes as input a function and produces output another function. So being more specific, this verify is not just differentiate with respect to x, because what we will see later on, you can have lots of variables flying around, x, t, y, theta, and you want to say, hey, I want to differentiate with respect to x, but first I want to differentiate with respect to t or y. So you need to be a bit more precise. So whenever you see this ddx, it's actually like a function, or well, it is what we're going to call an operator. You give it a function, it operates on the function and produces another. And we've got ddt and ddr, for example. ddt, which means differentiate with respect to t here, and it goes at it with an null product rule, or ddr, differentiate with respect to r. Now we've got some more operators here. the constant function 2 being sent to 2x plus a constant, the function sine of x being sent to minus cos x plus c, and the function x to the 4 being sent to x to the 5 over 5 plus c. Now these are antiderivatives, so the I here is anti-differentiate. That is an operator. Now the other one is differentiate twice. Sine x differentiated once is cos x, differentiated a second time is minus sine x. Differentiate this twice. We go from x to the 4 to 4x cubed to 12x squared. So this s is the second derivative with respect to s. X will be more precise, and we write this something like this. So this is like differentiate respect to x once and then again. And therefore this is like squaring this, differentiate respect to x twice. And you can write it like this. This means differentiate twice with respect to x both times. And we're going to see different differential operators, and we're going to see functions that depend not on a single number like x to the 4 but on two numbers, and you'll be able to differentiate respect to x and y. So we're going to have these guys, and you're going to have products of these. For example, differentiate respect to y and then differentiate with respect to x. You should write something like this. So differentiate twice, first with respect to y, then with respect to x. You're going to meet more transforms / operators next year. You're going to get the Laplace transform, which is going to help you solve differential equations, and the Fourier transform, which I think is going to help you solve partial differential equations. So basically the story here is that these operators, something like differentiation, anti-differentiation, they take in a function and spit out another function, and we'll have to be very precise. We can't just say differentiate, we have to say differentiate with respect to x or whatever the case may be.